right, have your homework out if you would, please. Books open to page 329, and I'll go and get my book out and open to page 329. We were doing number 3, A through D. So we were using the functions that we've done, or a couple of the functions at least, that we've done in the previous night's homework. This is the very last page of material in your book. You flip over, that's the glossary right behind it. You feel moderately accomplished? I mean, if you overlook the fact that we skipped like 3 chapters. But anyway, so let's go and take a look here at what we did. Number 329, or page 329, number 3a, we were using a function of x is 2x plus 3. They wanted us to integrate the function between 2 and 10. So finding the area under the curve from 2 to 10. First thing we have to do, of course, is integrate the function. And we could cheat and look back, or it doesn't take that long to just integrate it again. What do we get when we integrate the function? Jamie?
It's x squared plus 3x plus c.
There we go. And we're going to evaluate it then between 2 and 10. I said for our purposes, what's always going to end up canceling away anyway, class?
The c.
The c. So really, truly, we can evaluate the 10, subtract the evaluation of the 2. If we plug in the 10, Quentin, what do we get?
130.
100 plus 30, which of course is 130. We can do that in our head, so why not? And then when we evaluate the 2, Jamie, we get
6. Where did it go? 10.
10. 4 plus 6, which ends up giving us a 10. And of course, 130 minus 10 gives us 120 square units of area. Now, if you're watching on YouTube, in the description is a 5-page handout. And the first page of it actually shows the graph. I'm going to show my students here, but this will be better for you if you just pull that handout up rather than trying to look at this on a screen. But there's a graph of the function, and there's 120 boxes shaded in there. So you kind of get a feel for what that function looks like. Again, YouTube, just look at the first page of that 5-page handout. Let's take a look at letter B. This time the function of x, again a linear function, negative x, negative 4. And we're going to integrate f of x with respect to x, this time from negative 8 to negative 5. So again, we need to start by integrating the function. Quentin?
Negative 1 half x squared minus 4x plus c.
Minus 4x, you said?
Yes,
Plus c? All right, and we'll integrate or evaluate then from negative 8 to negative 5. Now the negatives are going to make things mildly annoying, but we're going to roll with it anyway. We're going to plug in the negative 5. We square it. That's going to give us, Jamie,
25.
positive 25, and then negative half of that, negative 25 halves. All right, we'll just leave it as the improper fraction for now. And of course, negative 5, negative 4x.
20.
Positive 20, negative 4, I should say. Negative 5 is the x. Again, we're ignoring the c. We'll subtract the evaluation of the negative 8. Quentin, we square the negative 8.
64.
Negative half of that.
Negative 32.
And then negative 8, negative 4.
32.
Positive 32. And of course, we can see here that the negative and positive 32s cancel. So really, it's just negative 25 halves, or negative 12 and a half, plus 20. And we end up getting what for the area here? 7 and a half. Careful when you borrow, like 19 and 2 halves. 7 and a half square units of area. If you're watching on YouTube, look at the second page of the handout. Here's our function this time, and you can actually see the 7 and a half boxes if you wanted to count them. And again, it's positive area because it's above the x-axis. Looking at letter C, evaluating f of x, which was x squared, negative 6x, positive 3. Finding the area. Now, is it negative 1 to 0 in your book?
Yes.
Okay, my book originally said 0 and negative 1, which is backwards. Yeah, so negative 1 to 0. Integrating f of x with respect to x. Jamie, the integral?
The integral is 1/3 x cubed minus 3x squared plus 3x plus c.
And again, it's going from negative 1 to 0. The 0 is really easy to evaluate, class.
C.
0. Well, c technically, which again, we're ignoring the c. So just 0 minus, so we're basically going to take the inverse of whatever the negative 1 evaluation is. Jamie, here we plug in a negative 1.
And the negative 1.
Times a third.
Negative 1/3.
Square the negative 1, Quentin.
1.
Times negative 3.
Negative
and then negative 1 times 3 class.
Negative 3.
So we get negative third, negative 3, negative 3. This all comes to
Negative 6
negative 6
and 1/3.
and a third, but we're going to take the inverse, so we get positive 6 and a third square units. Of course, YouTube, look at the third page then, and you guys, here's our function. Now, the function actually dips down below the where the graph shows, but you can see the portion of it here, and there's our 6 and a third boxes just in that one little sliver there. So that's the graph of the function. And then finally, letter D. And I'll start over on this side here. Let's see, given, now this is going to be an inverted parabola, isn't it? Because we have the negative leading here, negative 3x squared, positive 6x, negative 5. And we're integrating f of x with respect to x, this time from 0 to 2. All right, so we start by finding the integral, Quentin.
Negative x cubed plus 3x squared minus 5x plus c.
And again, evaluating from 0 to 2. Again, drop the c. The 0, for all practical purposes, we don't need to bother with. So really, we're just evaluating the 2. And when I evaluate the 2 right here, I end up getting class negative 8,
12.
positive 12,
Negative 10.
negative 10, and we end up getting negative 6 square units of area. So we've got an inverted parabola, and the area between 0 and 2 is below the x-axis. Again, look at that fourth page, and here you've got the inverted parabola. Almost looks like a molar or something, you know, like in a dentist's office. Anyway, but you can see the 6 units of area, but inverted and going downward. Questions on finding area with definite integrals?
So we always, when we're subtracting, we always have what's listed first.
The bigger number. So again, as you're picturing the x-axis, the first x value is the bottom, the second x value has to be the top. So the bigger number always goes on the top, the smaller number is always on the bottom. Yep, good question. That's why it would have been wrong for letter C in the original printing. They said between 0 and negative 1, and I corrected it in my book and said no, negative 1 to 0. Someone else called in and complained and they fixed it. Anyway, questions on that? All right, go ahead and set that aside if you would, and let's do just a few more practice problems with some indefinite integrals. Again, the primary purpose of the integral, finding that area. Let's practice with some indefinite integrals also. Specifically evaluating the C with more given information. Let's take a very basic function of x. F of x equals 4x negative 3. Wanted you to integrate f of x with respect to x. Notice no upper and lower limits specified. That's what makes this indefinite. But going to be given more information that capital F of 2 is negative 1. And I got another one for you in just a moment once you finish that. Finished? All right, let's take a look. First of all, we need to find capital F of x, and Jamie on the first one.
X or negative x cubed. Wait a minute. Oh, I'm on the wrong one. It's 2x squared negative 3x plus c.
There we go. But instead of leaving it with plus c, we can get more specific because we have more information.
Mm-hmm.
We can actually replace the plus c here in a minute with a number, but we have to find it. What do we do to find
We
it?
plug in the 2, and it'll give us 8 negative 6 plus c, and then it'll be equal to negative 1.
Right, all of that's going to end up equaling a negative 1. Well, as it turns out, when we do the math, c comes out to a
1, right? Oh, negative 3.
negative 3. There we go. So our final answer?
The 2x squared minus 3x minus 3.
There we go. There's our final answer with that little replacement of the c at the end. Is this what you had, Quentin?
Mm-hmm.
All right, Jamie?
No, I see. I did something. I think I squared the 2 to get 4, but then I forgot to multiply it by 2.
Gotcha. Okay, so you had a 4 minus 6, and that would explain where you got the 1 from. Okay. All right, let's come over here, Quentin. First thing we need to do to integrate, again, indefinite integral. We're not finding area, we're just finding what the integral itself is, and that's to find capital G of x.
X cubed minus 7 halves x squared plus x plus c.
All right, and then we want to, again, replace the plus c, so we'll evaluate
Capital G of 3 equals 27 minus 63 halves plus 3 plus c equals negative 7 halves.
All right, and let's see, this here is a 30, right? Now, if I were to change that into halves, 30 is how many halves?
60 halves.
60 halves. So I've got a positive 60 halves, a negative 63 halves,
Negative 3 halves.
but we're going to move it over as a,
Also
and when we do, we end up with c being equal to
negative 2.
negative 4 halves, which is just negative 2. So our final answer for g of x, or capital G of x?
X cubed minus 7 halves x squared plus x plus minus 2.
There we go. And there's our completed answer. Questions on this? This is what you had, Jamie?
Mm-hmm.
All right. Any questions at all on these? All right, let's do a little bit more practice with area then as we finish up our chapter here with calculus. Got another worksheet for you. And again, if you're watching on YouTube, this is the 5th and last page of the handout. I've got a graph actually provided for you. So you can kind of count if you want to and estimate the area in advance. Then do the work and see if your answer is pretty close. Okay, so again, to take an estimation. You don't have to count and estimate, but it does give you a good way to determine how close you are. So it should be within 1 or 2 square units probably of your estimated answer. Take a few minutes to work on this worksheet, finding the area using definite integrals. And we'll take a look at these answers here in just a little bit. Some people's kids. I think the Spanish class temporarily released students to go get something. I saw Spanish students out there, but it wasn't a plethora of others. I don't know. They just make a lot of noise for a few people. That's what it is. Looks like our students in here are on their last one, so we'll be finishing up quickly. Obviously, if you're watching and you need to pause once we get ready to go over answers, that's fine. Pause till you finish. Just a couple more minutes probably to be finishing up in here. Everyone's got all three? How close were your guesses to the actual answers?
I just did the problem.
You just did the problem, so like, I'm not gonna guess. I'm not gonna mess this up. I don't need to guess to check my work. That's confidence, I like it. It might also be laziness, but as a mathematician, I'm not gonna condemn that either. All right, let's see how we did. The first one here, first thing we should have done was, again, pause the video if you're not finished on YouTube, was find capital F of x. What was your initial integral here, Jamie?
1/3 x cubed plus 1x squared plus 2x plus c.
There we go, and we're evaluating from -1 to 2. Again, we're going to drop the plus c, so we're really just plugging in the 2. And when we plug in that 2, Jamie, we end up getting
-8/3. Oh,
-8/3?
Oh, for the 2?
Well, for the 2, yeah, we're plugging in 2.
Well, I had 8/3 plus 4 plus 4.
There we go, and then after the minus sign, we're plugging in the -1 now.
Then it's going to be -1/3, then just 1, -2.
All right. Again, I would combine where I can to get 8/3 plus 8. Combine this to get a -1, but because of the negative, it becomes a plus 1/3 plus 1. 8/3 and 1/3?
9/3.
9/3, or
3.
3 plus 8 plus 1 comes to exactly 12 square units. And curious, did you guess 12 before working it?
I guess 13.
13. So you were within us 1 or 2 square units of it, so that makes you think, I think I did a good job on that guesstimation, so I'm reasonably certain I did it correctly. Again, if you got some crazy answer like 38, you know there aren't 38 boxes there filled in, because you counted already, estimated, right? If you came up with negative area, well, that can't be it, because everything's above the x-axis, right? So there we go. Quentin, are you good to go with 12 square units? Look at the next one. What was your initial integral, Quentin?
1/4 x squared plus 4/3 x cubed minus 2x plus c.
All right, and again, we're going to evaluate this from -3 to -1. On the surface, you see negatives and you assume negative area, but looking at the graph, obviously we're going to have positive areas still. We'll drop the plus c. We'll evaluate the -1. Kind of tell me how we plugged in the numbers here.
1/4 minus 4/3 plus 2.
All right, and then when we plugged in the -3, how did that end up going?
1/4 minus 36 plus 6.
There we go, and I would say that -36 plus 6, of course, can just become a -30. So we've got a -81/4, we got a positive 30 as we change the signs here. I've got this positive 1/4, -4/3 plus 2. I can at least combine the 2 and the 30. 32, again, this is if we're trying to avoid reaching for the calculator. 1/4 and -81/4. -80/4, but of course that's just -20. So I got a 32 and a -20, that's 12 minus 1 and 1/3, or -4/3. If you have 12 pizzas, somebody comes along and eats 1 and a third, that leaves us with 10 and 2/3. Square units is correct. Jamie, what did you guesstimate it?
I guessed 10, but then I had an answer of 5. I was having a hard time with this one.
Okay. Did you figure out somewhere?
What I should have done.
Where did the mistake happen for you?
I think, of course, it didn't help. I switched it again with having the. I think I have a -3 first, then -1.
Oh, okay,
and
yeah.
Just like
The big number first, the small number second. And again, we think of, -3 is bigger. No, it's smaller, right? Absolute value is bigger, okay?
And then I think just adding errors.
Okay, now again, you could just use the calculator. So if you wanted to, assuming you put it in the right spot, you want to do 1/4 minus 4/3 plus 2. In fact, do that on your calculators really quickly. Let's make sure we're proficient in that. I like not using them, but let's make sure we're proficient. 1/4 minus 4/3 plus 2?
11/12.
11/12. All right, now 81/4 minus 36 plus 6.
Negative 9 3/4.
Negative 9 3/4. All right, but we have a minus in between them. So we can do 11/12, and we don't need to do minus the negative. We know that's going to be a plus anyway. So 11/12 plus 9 3/4.
10 2/3.
And there's your 10 2/3. So again, the calculator can do it, certainly. I don't know. I like the exercise of not using it, but I'm certainly not going to hate on you for using it either. And it's really, frankly, it's good to be proficient with that. Questions on this? All right, let's take a look at our last one here. And we had our function of x. Well, you can see the function of x. Let's go straight to the integral. Jamie, what did you get for your initial integral?
Negative 1/3 x cubed plus 2x squared plus 3x plus c.
And again, we're going to drop the plus c. We're evaluating from 1 to 4, which means, again, which number are we testing first, Jamie?
The 4.
The 4 is what's going in first. So we plug in the 4 and we get,
64 thirds.
well, negative though, right, because of the negative here. So negative 64 thirds.
32, 12.
All right, then we're going to subtract what we get when we evaluate the 1.
And negative 1/3 plus 2 plus 3.
All right. And again, if we wanted to, we could say, well, that's obviously going to combine for
44.
44. And this is, of course, going to combine for
5.
5. But because of the negative, we have negative 64 thirds plus a 44 plus another third, and then minus the 5. Let's combine the 44 negative 5.
39.
39. And if I have a negative 64 thirds positive 1/3, that's,
Negative 63 thirds.
but we can divide that out. It's negative 63 thirds, that's just
21.
negative 21. And so our answer comes to
18.
18 square units. What did you guesstimate it?
17.
17, really close. Did you get 18 square units? And good to go on that. Any questions on this? Or do we feel ready to take a quiz over integrals? We're good to go? You know what we're doing? All right, set the handout aside if you would please. How about just a blank sheet of paper and a pencil and a calculator? Blank sheet of paper, pencil, and calculator. Everything else away. Your last math quiz I will ever give you. After all these years of giving you math quizzes, this is the last one. It's okay, we still have a test coming up in lesson 166, so it's okay. There's the exam still, but not for Jamie. That's why Quentin's salty today. He's bitter at Jamie. All right. This is quiz 50. I want a nice round number here. Pre-cal quiz 50. I use the quiz copy as a cover sheet. Numbers 1, 2, and 3. Find the indefinite integrals. Number 3, you've got a little extra information there, so you're going to have to do a little bit more work to finish out the full answer. And then number 4, I've given you a picture. I want you to find the area under the curve. You can use a guesstimation, obviously, to check. I'll leave your answer in square units. All right, you may begin. And there is no homework, so we'll end the video here. Just remember, test coming up in lesson 166 we'll be reviewing in our lesson tomorrow.